Today I will be going to talk about one of my project which I have recently done for one of the defense hackathons, which is also called the EUDI's Defense Hackathon 2025. This defense hackathon actually is presenting three challenges today. So the challenges presented by the defense hackathons are either you have to provide a solution for an enhanced situational awareness and tactical surveillance systems, or it may be like a cost effective prototyping gear for frontline defense, or on the other hand you can also provide solution for a challenge like advanced medical support for frontline care. So after going through all the problem statements, then I decided to go with one of the challenge. That challenge which I choose is the advanced medical support for the frontline care. So here you can there are more possibilities that you can also develop certain things which can help the medics as well as the soldiers in many ways. So you can either develop an advanced AI driven tools that actually helps the medics and the soldiers in like quickly diagnosing the injuries and determining the priority of the care under the high pressure conditions. So this is very important. And one more thing, that is you can also help the soldiers or the medics mainly to assess the injuries through various technologies or through various AI driven technologies, like maybe like image recognition, and also helping them to predict the vital signs of the casualties, which will again help them to categorize them based upon the vital signs. The medics can, or the AI tools can categorize them to risky, or say medium risky to low risky patients. So and also based upon this, then you can rapidly make decisions to whom to treat and whom to give less priority, or else you can also give us build something like for automated triage systems that allocate the resources available in the hospital based upon the injuries, based upon the severities, and based upon the stage of severity the casualties are at the point in time. So now today I have built something like this. So yeah, this is my solution. Okay, this is how my solution will look like on overall. So here it will be divided into three parts. One is the dashboard, that is nothing but the front end, and in the back end there will be a database, and there will be AI predictions, and there will be agentic frameworks. So basically what I have done is I have treated each patient as each soldier. So as soon as the casualty comes into the hospital, they are connected to the hospital service and their vitals are read. And as soon as I get the vitals from the patients, say I am getting vitals from the soldier 1, since I have a database, the agentic framework is handling everything. So since I have a database of the data which is related to this soldier, this is extensively collected during his training or any of the combat operations which he has taken part in the past. So I have this data. So according to these data, I can now say if say his vitals are x, y, and z, what will be his future vitals. So x plus 1, y plus 1, z plus 1. I have models that have been trained on this soldier's data, which is now capable of predicting his future vitals, and this will act as a prompt. So now I will use these vitals along with my prompt, and I will provide it to the my LLM model. So this I will consider as an LLM. So now what I will do is, as soon as I give the data, the LLM is connected to different tools. So say you have LLM tools which is connected to a medical database, or a medical what you can say, like a medical protocol database, which will provide me certain medications, certain ways to treat the patients based upon the vitals. And also it will be connected to the database of the patients, medical uh, history, and also the treatments which he is undergone, or what kind of medications he was under. Okay, and this will be my query. And you will get the context from here. You are going to collect the context from here, you are going to context from here, and you are also going to collect the context from any kind of rules, or you can say like any kind of army related protocols that you have to follow during treating these kind of patients. So you get a context now. So then you will decide. So based upon this, the LLM will decide what kind of category he is in currently. He can be under the risk of high risk. He'll be categorized into three categories: high risk, medium risk, or low risk. And he will be given the confidence scores, which you can also see on the front end dashboard. He will be given confidence score based upon whether he's at the high risk stage, or he's at the medium risk stage, or he is at the low risk stage. And now based upon this, again my query, the initial query will be rewritten. The query will be rewritten by taking the various parameters. Here the parameters will be like confidence, the injury detail from the medical personnel who is treating this. So he's also writing injury. Injury will be also a part of my query. So now query will contain all the context from his medical history, the database of patients, treatments, or other patients who are also been under the same conditions, or the rules of the armies. So this will next fed into one more LLM, and this will generate me a detailed treatment plan. Okay, so this is the idea, the basic idea behind it. So which is you can see also here. So the patients are nothing but the soldiers, so they will be communicated to the my main system. So that is nothing but my LLM model. So you will be giving the, here also there will be an LLM model that will be taking the inputs, creating a query using the vitals from the patients. So it will be connected to different retriever tools, as I just mentioned here. This will be connected to different retrieval tools, and based upon it, it will decide what kind of actions can be taken. There are a lot of things that I have planned, but I could not implement because of the time constraints. So for example, deploying medical services with the help of drones, robots, medical info intelligence directly into the place where the casualty is first found, but that is not practically possible right now. So I just made it simple. So I am trying to build an MCP based autonomous orchestration model. Sorry, this is orchestration model. And so this is one of the framework or the architecture which we can use when we build an LLM models. Okay, now this is how it looks. Now I'll explain like how the coding part will look like. Hello. Now I'll try to explain the code which is built on the theory which I explained just now. So this is nothing but an agentic AI framework. Here I have tried to create the corrective rack systems wherein your node will automatically correct itself when it feels the reason which it is giving is wrong based on the query which is given. So now how does it work is nothing but it's a triage. Oh, sorry, the class triage.
Okay, let me explain what is first, what are the packages I have used here. So I have used a UV. So UV Astral is one of the fastest, uh, what you call the Python package, which is used instead of pip. I have replaced pip with UV. It is much faster than like 10 to 100x faster than pip. It helps in installing your all your dependencies, all your package files. It's the same as pip. If you don't have UV already installed, you can just do pip install UV, and uh, you can initialize your you can initialize files just by doing this UV init. It will give you 4 different files. That is nothing but your package files and everything. And if you want to create an virtual environment, you just have to do UV venv and then a space. Then you have to give your name of your virtual environment. Unless and until you give anything, just creates a virtual environment in the name of venv, just as it is mentioned here. It creates 4 different files, and I would say like one of the most important files would be toml, because it shows you what all the packages you have installed. My dot requirements file actually contains all the packages which I have installed, and if everything is successfully installed, then that you can see it in the toml file. This is one of the most advantages uh, of the using UV package, because when you use pip, you just have to do pip install. If you say like if you want pandas, then you just install pandas, but it will never show you like you will never know. For example, if you have done it today, then tomorrow you will never know like what kind of package, what version you have installed. So but in the UV, when you do it in UV, it actually tells you. Even if you open 10 days after, then you exactly know like which version of what package you have installed. So this is one of the main advantage. And my .env file contains all my environment variables. That is nothing but I have just stored my Grok API key. Since today I'm using open source Grok models and Hugging Face. Here I've used API tokens because not API tokens, just tokens, because here I have stored my model, which is trained on the dataset, as I just mentioned, which is obtained from the Kaggle, so of the soldiers. So it's just basically a rough dataset or a trial dataset on which my model is trained. And coming into the so now, when the patients are the casualties are connected to the hospital service, you have to read their data, right? How you can read their data? Because in the end, when you create your own dashboard, you have to actually see what is happening with the patient. So for that, I have created a simple server. I have used OPCUA. This is what it's one of the knowledge which I got through my job. So this is OPCUA is nothing but open platform communication for unified architecture. This is basically used in industrial communication. This has nothing to do with this project, but just it helps me to create a client server architecture. So here I have created a server. In the server, I have logged in all the patient's data, and it keeps on running. So it keeps on running, as you can see here. It keeps on running and gives the data, continuous data of the patients. Like it's just like it's giving your heartbeat. So it keeps on updating, keeps on updating, keeps on updating. Just like this, it keeps on updating, keeps on updating. So you can use this data, and I will use this data as I will show how when the dashboard stuff I'll explain. And now directly jumping into the implementation. So this is how my implementation will look like. First, I'll talk about the state. The state is nothing but it's one of the most important parameters, or one of the most important property in agentic frameworks. This is state represents the the schema, or the data type of all the parameters which you use in your frameworks. So for example, if I use soldier ID can only be string. In my case, it's always a string, as you can see here. It's 1 2 3 4. It can be like a soldier ID 3, soldier ID 4. So here I treat everything as a string. You can treat it anything, but I have treated it as a string. And vitals is nothing but all of these things: the heart rate, the respiratory rate, the temperature, the SpO₂, the blood pressure, the HRV, everything. And the classification is nothing but the priority which you give here. So that is nothing but the minor or delayed, or you can keep it as anything what you want, maybe red, black, and yellow. But I've kept here immediate, minor, and delayed. And then coming into the rule category, this is used in the nodes. I'll explain in the, you will see in the future. Now in the next steps, rule category, rule priority, reasoning. Reasoning is nothing but what kind of reason you can give for the current condition of the patient, and the treatment plan is generated basically by the agent. Okay, so DNN model, this is just a structure of the model which I have used for training the data which I obtained from the Kaggle. This is how it looks like. These are the layers which I've used here, and load model. So I can show you like where is my model. You have to just go here. This is my Hugging Face. So for example, if you want to, you have to create your own space first of all, and then what you have to do is you have to go into your, as you can see, uh, as I've already created my space. So my models will be stored here in G1 under the name of G1 1998 is the name I have given. So it will be stored here. So these are all the meta files that we'll be having. So .ptg file, that is nothing but is also the metadata, label encoders, all the weights in scalar and label encoders will be stored here. You just have to copy this and go here into your model, just paste it here. Like, it will download the model from there. It will download the model, it will download the meta files, it will download whatever the weights required from there, and then it will you can use it in your code here. And then comes creating the node right now. So in the nodes, okay, first I'll explain how we have created it here, or else let me put it this way. First I'll show you like how does it look like. It'll look like this. It'll look like this. First I'll start. I have created the graph already, so I'm just showing you how it is created. So I'll start from here. I'll classify the patients as being minor, or either being under severity or not severe. Then according to rule logic, you will say like what has happened, because you are also mentioning the medic will also be mentioning the injury that he can visibly see, so that he can also tell the LLM model more information about what is happening in the real time. And then this will be helping to generate the reason. Like reasoning will be just like to say like based on this condition at the present, like what can be his current situation. So, and next it will be this, along with this context, it will be fed to the general treatment, that is nothing but as a query into the LLM, the final node, and it will generate you a detailed plan depending upon his current situation, current reasoning of what his conditions are, and it will give you a detailed treatment plan. So yeah, this I have already run. Okay, here there will be nodes. One is classification model prediction, as you just saw there. So if I can, I will try to split it and show it to you. Prompt. Then here also I will open this so that it will be easy to follow. Yeah. Okay. I'll start this start node, and then comes the classification node, and then comes the rule, the classification node. The classification node will look like this. So it will basically categorize yourself based upon the predicted values. As soon as the patient is connected to the system, the model starts running. The model will predict his future vitals, and based upon his future vitals, now my classification model will be saying like under which category he is falling. He's falling under risky category. He's falling under what kind of category, or not risk category. So next comes the rule logic. So rule logic is nothing but a rule-based category. Again, as I just mentioned, based upon his current situation, the it is basically telling you like what kind of uh, in what area he's lying. So basically, if I go into the triage rules, so in triage rules, if you can see here, it is telling me if his SPP is less than 90 and heart rate is greater than 130. This is very basic. I have kept it here, but you can make it more complicated. You can add more variables here, and it can be made more complicated as well. But here I have kept it very simple, so that whenever if you say like his blood pressure is less than, sorry, SPP is less than 90 and heart rate is more than 130, then he'll be categorized red. and in the same way it will be categorized depending on other situations. It will be categorized yellow, black, and green. Okay, if he is not under any of these categories, then he'll be, of course, he'll be in the state of green. That means that he's safe. So this is what the rule-based category node will tell me. And next is after this rule-based generate reasoning. So generate reasoning node. So this node, what is it doing? So this node, based upon its current vitals, based upon its current triage system, it will give me a reason, like what can be the reason why, because of this he is in this situation right now. So because it will take a context from the previous nodes and it will generate the reasoning. And next node is the generate treatment. Here it will take everything. Basically it will take the context from here. It has a context from generate reasoning. It knows what is a rule and what category he is falling in, and it also has the classification of the patient. That means that the model is already knowing what kind of patient he is, what kind of medical treatments he's undergone, what kind of past medical history does he have. So based upon this, my model will be generating a response. I have just simple prompt. I have kept it very simple. I have generating a battlefield treatment plan with the current vitals of him, which will give me a detailed treatment plan, which you can see here in the output. I'll show you. Next is building a graph right now. I have to import state graphs. State graph is nothing but a graphical library which you use for creating the graph-based flow of the diagram. So create graph, and try system is the state schema, as I just mentioned. Next is nothing but adding the nodes. You have 4 nodes here. One is classification node, one is rule-based node, one is generate reasoning node, one is generate treatment node. And in the flow, you have to add the edges. Edges is nothing but the lines which is joining the nodes. So you set entry point. This actually you can also do this instead of you can also do this. Start. I mean, sorry. Start. You can just do this instead of that. Okay. If it's not installed, then you can directly go here and install it. Okay, I think yeah, this works like this as well, because you can no need to then put an set entry point. You can just put add edges. Yeah, you can just put add edges. This basically means that you're connecting the nodes. So you start to classification patient to rule logic to generate reasoning to generate treatment. That means that the flow of information will be sequential here. So flow information will be flowing through each nodes. So each nodes exactly knows what is the state, because state schema will be shared among each nodes. So whenever there is a changes that is happening in a particular node, then the state schema will be updated. The keys is basically nothing but a key value pair, as you can see in the state graph. I can go to state graph. Yeah, in the state graph you see this is a key value pairs, right? I mean the soldier ID, here you will be having values, you have vitals, you will be having the dictionary values, injury, you will be having values. So in this way it will be stored there. So it will be shared among all the nodes so that you can use it in any nodes here. So they exactly knows what is happening. Next, you build the graph, you compile the graph. This is simple. Now the sample input, I have just put, so all the inputs that you can see here in the state schema, you have to give it. So it will be, there's no rule that you have to give it. You can give it, or you can also skip some of those according to your needs. So here I have given soldier ID, that is must, you have to give. I mean, it is actually automatically being fed through the soldier ID server that I will show you in the next. So here, since it is a sample execution, I have just kept it as 01, because here I can put soldier 1, soldier 2. Then injury is nothing but, what is this? Okay, sorry. Gun wound to the chest. I have just kept it. You can also put like you can also put like with severe bleeding around the chest, not around the chest. I'll put around severe bleeding around the head. Gunshot wound to the chest with a severe bleeding around the head, or else you can also put chest as well. Now it doesn't matter, but actually the medic will feed in the actual scenario that they can see in front of their eyes. And this again, heart rate, respiratory rate, SpO₂, body temperature, SPP, this everything is fed by my server. So where is my server? I can show you my server as well. My server is here. So these all the things which you can see here is spread through here, spread here. Okay, automatically it's going to the model. So then the classification, it's a placeholder. Rules category, I've kept it. Rule priorities will be filled when the state schema keys are filled. So this everything will be filled, and then I will be invoking my graph. Graph is already created here. So after you create a graph, you compile it, and then you create a what you call it, you invoke it. So it's a sample state right now, and I've just tried to print my result, uh, and here you can see, yeah, here it is exactly giving me what does my treatment plan will look like. So based on the vital signs and injury presented, since injury you have written it as a prompt, I would categorize this patient as triage category yellow. This is what my model is saying. He will be categorized not as a safe patient, not as a critical patient, but as a yellow, indicating delayed transfer or treatment. Now the patient's heart rate of 130 BPM is okay, tachycardic, but within an expected range for someone who has just been wounded. However, their systolic blood pressure of 90 mm. So this is the detailed explanation of how to treat the patient and what based upon his current conditions. This is treatment plan generated. Now what I do is I'll create a now I'll create my actual I'll show my actual project. This is just my prompt I have just created to show in the video. But the project is actually here. I can show it to you. The project is a modular. I've created a modular project. This is how actually the projects are created. So I created a source file. In the source file, I'll be having different things as you can see here. I'll be having my graph. I'll be having my models. I'll be having my nodes. I'll be having my state schemas. I'll be having my helper functions. So this is how it works. Now, first of all, I'll start creating my models. I'll create my grok models here. Everything grok API keys are already loaded. You have to. This is simple, like you're loading your API keys from the environment variables. Then you are initiating your LLMs, and then I'll show you my nodes. Sorry, next I'll create my state schema. State schema will be exactly looking like this. So here I've used two state schemas, one for actual operation and one is the way the okay, I'll write it here. This is the way in which my LLM or my LLM model or my agent has to give the give the output as. So this is how the output should be obtained by the model, and this is nothing but the triage. This is the actual state schema, but this is not the state schema. This is nothing but uh, this is I am mentioning how does the output should look like. How does the output from the model should look like, that I'll explain again later. So now this is the actual state schema. Okay, this is my actual state schema, and this is my uh, a schema for my LLM model, because I want my LLM model to give the output as mentioned here. It has to tell me which soldier, what is his vitals, what is his injury, what is his classification, what is rule category, what is rule priority, reasoning, and also the treatment plan. Okay, this is for my LLM model. This is for my state scheme. This is my state. Okay, next starting with the nodes now, creating the nodes, then the last graphs. Okay, here again I have, as I just mentioned, I will be having four nodes. This classification node, rule based node, generate reasoning node, and generate treatment node. This is exactly the same way I have this. There is no much changes here. Only the retrieval nodes are there, so which will retrieve the information from the databases. So only that is there. Nothing extra I've created here. And next will be my graph. In the graph builder, I'll compile everything. So I will call everything. I'll call my triage system. That is nothing but my model output schema. This is my state schema and the nodes and my LLMs. So everything is there. Then I create my graph. Again, the same graph will be created in the same way. And now again, you will compile. Actually, this below code, this is actually for the line split, which I'll explain later. But now I'll test my implementation. For testing, I'll use Postman. Postman is one of application where you can also test your API endpoints. Before that, I have to show you like how does the endpoint is created. How does the API? Here I use Fast API. Oh, basically, I'm using REST API. REST API is nothing but a design framework, but Fast API is nothing but a Python uh, web API framework. So I have created my app. App is nothing but the endpoint. Now I'll be hosting it on the endpoint called as Triage, which I'll show you how, and then it will be hosted on the port 8000. So here, if I don't mention the port, it will take automatic port. So that's the reason I have told you like um, uh, did I mention? I think I've mentioned that I've created a separate thread for my process. That's the reason I have created a thread here, which will keep my server separate and all other ports separate, since I want my server to keep running every time in order to open my dashboard. So that's the reason I have created a separate thread for my client, I mean the server. Now where was I? I was explaining about the fast API. Okay. Now here. So now, how does your input should look like for an API endpoint? You need to give certain important things. That is, you need to give your injury that the medics can see. You need to give the soldier ID, and also you need to give the soldier ID is required by the model to identify which soldier, because it has to retrieve the content about him from the database. And one more is nothing but the injury which you will be giving. And also actually the vitals has to be fed. The vitals are actually fed by the I will create a client that will actually feed all my soldier data from the server into the model. So that's why, but here I have to manually type in the vitals and injury as I just mentioned. So these are the main important things that has to be there. I think I have created it in the request.json file. It should be there here. If it's not there, then I can show you like how it does it look. It should be there. It's not there. Okay, it's not there. Okay, fine. But I'll show you like when I will open my API, then I'll show API endpoint. I'll show how does it look like. Next, it will be posted in the form of a JSON file. That is nothing but in a JSON format into my endpoint, and then you will again initialize your model, call your model, and then you build your graph, and then after building your graph, you just invoke it, and then you return the data. So this is how simple API endpoint looks like, a fast API. And then getting into for checking my output, I have to just feed in, as I just mentioned, I have to just feed in my soldier ID. You can change the soldier ID. I just get it. You can change it to severe blood loss from the head. I can change it to something else. Like I can give like um, severe uh, head injury with three bullet three bullet three bullet shots. Three bullet shots just be below the chest. This is how I view right now. And heart rate and all, I've just mentioned it randomly. And gender, since I have label encoded, this will be like 1 means male, 0 means female. So this is how this is how my model has been trained. So that's the reason I have to give it in the same way. Now, as soon as one more important thing, you have to post it here. You're posting your what do you call the request into the endpoint. So your endpoint is in HTTP 1.0.0 8000 triage, and I think your endpoint should always be running. You have to run this file first, otherwise it will not run. So is my endpoint running? No. So your model will not run, your output will not come. So you have to run this app.py. You have to keep running this server, otherwise you will not be able to post your request into this endpoint. I think it will start now. Yeah, this is my grok API key, and then now it started. Yes, it started. Application startup complete. Now you go to your postman. Postman is like an okay, one more thing, important thing is You cannot use a Postman browser for testing because the browser for a browser, my local host, that is nothing but 127.0.0.0 of whatever port it is nothing but an external service for it. So it cannot access your own computer. You can only access the external APIs or external servers or paid stuffs. But if you want to check your own server, that is nothing but your own endpoints in your own machine, which is hosted on your own machine, then you have to use Postman desktop application. You cannot use a browser. So yeah, just you have to post your request into this endpoint. So HTTP 127.0.0.1, this is my endpoint, 8000 is my port, and Triage is the endpoint where my whole app is hosted right now. And you have to post a request. Here also one thing you have to keep in mind is when you go to body and put your the JSON format, you have to, it will be initially in text, so you have to make it as JSON. That's important. And then now as soon as you click on send, it starts it starts and you have to wait for some time that you will get the results. You can see the results here. Okay, now you can see the results here. The result have already come. The injury, I have just typed the same thing will be displayed here. This is the schema that I just mentioned you, that the output will give you. So this is exactly the same way how I have mentioned. I need the soldier ID. I told it I need the vitals, whatever the vitals of the past three values, and I have told it that I need the injuries. I told it that I need the classification. High risk, confidence score is 0. That means that he is under the risk of high. And rule category is yellow. This 0 is because I have trained the model in the same way. That's the reason the confidence interval comes 0. And I have trained, if he's not under the high risk, then it will come as 1 year. Since I have given it here because of his vitals are also too high, 110, 120, 130. If you remember, I kept it like below 90 as being a safer range. So it's everything is high, so it will be of course coming as a high risk. And rule category is nothing but under the stage of yellow, and a rule category is delayed. So that means that he still have some time. You can give him some time. And treatments are nothing but due to the patient's severe head injury and vital signs indicating hypotonic shock, we'll focus on addressing these life-threatening issues first. It is just creating you can even improve it by improving your prompt basically. I just have given a simple prompt, but you can give like a bunch of text for say like 20-30 lines of text to understand it, depending upon the number of tokens the model can handle. You can give as many as tokens or as many as their text you can. So airway management, ensure the clear airway by positioning the patient in a supine position with their neck in natural alignment. Use a jaw thrust maneuver to open the airway and maintain it using a nasopharyngeal airway if necessary. So this is not bad. If you see here, it's quite good what it has given in my first training. You can iterate more and you can make this thing work like anything, work smoothly, give you better answers, better results. So you can make it more advanced by hyperparameter tuning. The tuning of the models, the tuning, you can also tune the model, or you can improve your prompts, or else you can create more realistic scenarios. Since my scenarios might not be realistic, that's the reason it might give some vague answers or vague results. And now okay, my API testing is done, endpoint is done, now my results are coming. Okay, now one more thing I can do is I can show you how LangSmith works now. So in order to work with LangSmith, you have to do one thing. That is nothing but um, you need one important library here. When you see the requirement, you need this library to work with the LangSmith. It's a LangGraph CLI. You need the LangGraph CLI, and you need to type LangGraph. LangGraph. There. This you have to write here. Before that, one more important thing is you have to create a langgraph.json file. This will basically help you to push your graph into the LangSmith. So dependencies here means dependencies dot here means it will push all your files. I mean all the sorry, this dot means this is nothing but the taking up the location from which you want to pull. put your model. So depend, if you give just dot, then it will take the current working directory, and then it will after you select the location, and then you have to say in that location where is your graph. So it has to go here under the source, under the graph builder, your graph. That's the reason I just mentioned you when I'm talking about graph. This is below code is for the LangSmith LangGraph Studio. So it will push your graph into the LangSmith. So this is how it should work. And this is my LangGraph. I missed it. Okay, this is LangGraph. Okay, this is a graph because you're returning a graph here. So graph is nothing but your graph builder dot graph builder. Okay, spelling is wrong, but I'll not change it now. Graph builder dot build triage graph dot compile. So it will give me the graph, and that exactly the same graph you are trying to push it into the LangGraph studio of LangSmith. Okay, and then dot environment file is nothing but all your API keys, because LangSmith doesn't know what models you are using, from where you are using. You are using an OpenAI APIs, or you are using models, open source models from Hugging Face or Grok. Since I'm using Groks, so it has to know from where I'm using the model. So you have to come one step back and then go .env into the .env file. So it contains everything what my Lang Studio requires. So it's done. And now what I have to do is I have to just type enter LangGraph tab for spelling. Okay, LangGraph tab. Okay, now yeah, now it will automatically start. It'll automatically start. I'll wait, wait. Yes, it started. Yes, it started. Now as you can see, this is nothing but the graph. This is exactly the same graph which I have showed you there. So it has taken all the graphical layers from my code. So it also shows you how the node and its flow looks like. Yeah, it has again has classification of the patients, rule logic, generate reasoning nodes, generate treatment nodes, and end. Again, here also you have to give the parameters which will be actually given directly from the server. So here also you have to feed the vitals, which I'll just copy paste from here. I've already have it here. Instead of typing it, I will copy paste it from my sample data. So sample data. So this exactly has to be the in the way that you need to provide it in the key value pairs, key value. Okay. Then after this, you have to type in the injury. Let me type a different injury now. Uh, uh, he, or what can I type? Like he is, I mean not he, but suffering patient. I have to. So the ID is already given, so I can give like a patient is suffering from what I can give. Uh, Suffering from leg injury with visible uh, bone dislocation and with a visible bone dislocation. And you can also say like severe with you have to keep your prompt very clean so that the model can understand what you're typing. With the head injury, with head injury, the patient is suffering from leg injury, visible bone dislocation, and with heavy bleeding. And right, heavy bleeding from the head. Okay, this is what you have to give to the model. So this is I've given a little bit tricky injury query. So let me see like how the model will behave in this situation, because it also has a connection to the databases. Now let me see how does it will behave. Yeah, it started. It's now going into the classification patient. Now it's rule logic has been done, and now it's going to the generate reasoning. And yeah, now it's executing generate reasoning node. Next it has to go to the generate treatment node. Okay, now generate reasoning is completed. Now it's going to a generate treatment node. So this side I'll show you after once it is created. It's a bit weak right now. Let us wait till until the generate treatment is done. Okay, now treatment plan has been generated. Let me see how does it look like. Okay, oh, it has classified him as again as risky. So it's telling like 0.0 confidence score that I have just mentioned. As also I have, when I was using Postman, you have seen like 0.0 is nothing but a confidence score saying that at high risk. The patient is suffering from a leg injury with visible low. This is what I have written, and it has categorized him as yellow. And rule category, rule priority is again delayed. And this is the structure of the output of the model. So soldier ID 01 treatment plan. So it's telling me what else. Okay, insufficient names I missed. Okay, injury, leg injury with visible bone dislocation, head bleeding from a head wound. This is what I've written. And step-by-step treatment plan is given here. Initial and assessment and prioritization. Quickly assess the patient's condition and prioritize the most critical injuries. Given the patient's vitals, I would focus on stabilizing their hemodynamics first, circulation and wound care. Apply something tourniquet to the leg injury if it is not already in place. Okay, this is also not that bad, but it's not as good as what Postman has given. I feel, yeah, even I feel like, but the ultimately end of the day, the models are same. This is one of the biggest problems with the models. Since I'm using here Llama 3 models, you can also use other models. It again depends on what is the size of the token which you give, and what is the token size the model is trained on. So everything matters. So yeah, I think because of the randomness and some other factors, the model is not acting that good here, but it's still fine. Let me get into my code and we'll go forward. Okay, now I've seen it is working with LangSmith. I can track my models in LangSmith. Now I can also use it on the endpoints using Postman. Now, what else is left? The part left is my front end. So my front end is in my dashboard. Yeah, this is a simple uh, Dash app which is created by using a Plotly library. So Dash is nothing but a Python framework that helps you to create the front end web applications. So I've tried to put it the same way. I've mentioned everything here. As soon as I run it, you can see it. It's nothing here. I have just done plug and play here. I have just imported the components from my source file. I have my graph, I have my LLMs, I have my nodes, I have my state, I have my utility folders. I have just used it and then just plugged it here. It's actually not that tough, but you have to like plug and play, and then it works at the end. So now, okay, now I again have to activate my one more environment. Let me open one more environment, but it's in different folder basically. So I have to go there and activate because this Dash app requires many more dependencies. I have used Dash. You can use any front ends. You can just use Streamlit for a fast solutions. Or if you are familiar with React Native or React, you can use React. If you are using mobile applications, just create React Native. Use React Native. Okay, now what I have to do? I have to activate my. Where is my CD? Oh no. What? Why? Okay, sorry. Okay. Now I have to activate it. Okay. Now I have to come back again to where I left. Okay, now I will run this front end. Now let me see how does this look like. I'll not explain like my front end application. It's very simple. You can use anything. Here I've only used my Dash because I'm very familiar with my office use. So yeah, this is much easier for me. But you can use whatever you are familiar with. You can use Streamlit. Most of the people use Streamlit because it's very open source. Yeah, now it's created. Now it's opening. I have to wait for some time. Okay, now it has opened. Okay, now you can see here, this gives me a status of many things. One is the patients who are currently admitted, the patients who are in ICU, the patient's occupancy rate, and here it is giving me the live updates of the soldiers which are connected to my system: soldier 1, soldier 2, soldier 3, soldier 4. Okay, why is this image not displayed here? I think there's something, some small issue here related to the image, so it's not loading. I don't even, this image has not been loaded. Okay, leaving that apart. This actually tells me uh, like what are the number of patients that have been recorded in the last 6 hours. So this is how it looks like. And now here comes the soldiers. These are nothing but the soldiers who are connected to my system. And this is nothing but the reasoning what it is doing. As soon as it connected, it's categorizing them under high risk, low risk, low risk, high risk, high risk. This is done by my model, classification model, and this confidence score is given by my model again. This is 0 since it is high risk 0, low risk as I just mentioned, low risk is 1 and high risk is 0. And then the reasoning is model based triage category. He's at high risk, confidence level 0, low risk 1, same thing. And now here I have to connect to my LLM and tell my injury. Like for example, soldier, soldier 1 is suffering from brain. I'll tell brain hemorrhage now. Let me see what it is. Okay, brain hemorrhage. Um, and severe damage of the elbow bones. Let me see how does this answer now. Let me see how does this answer now. I have just created a generate the treatment plan. It is going to generate now. And what is the generated output? Okay, now my query I have given is soldier 1 is suffering from a brain hemorrhage and severe damage of the elbow bones. Okay, now what is brain hemorrhage monitor? Okay, airway. So now ensure a patient airway using an orphanagal airway is necessary. Provide supplemental oxygen via non-rebreather mask at 4 to 6. Okay, this is quite good. I'm saying like for at least for a first C, I can say like it's okay because it has talked about brain hemorrhage. Since my query contains brain hemorrhage as a keyword, I think it monitors the circulation and maintains stable blood pressure. I can't give any feedback because I'm not a person from medical background, but yeah, still it's fine, I believe. Okay, this is good now. Apply a splint to the affected elbow to stabilize. Okay, it's also talking about, it also has recognized a damage for the elbow bones. Okay, it's also talking about apply a splint to the affected elbow to stabilize, immobilize. Okay, notify the medical command. Okay, prepare the soldier 1. Okay, for the first, see, this is quite good. Now I'll save it as a PDF. So if you open as a PDF, yeah. Okay, now this is airway management, breathing support, circulation management, pain management, injury management. Okay, everything what was printed there, it is given here. And yeah, for the first took, I would say this is quite good. We have seen the Langsmith, we have seen the dashboard implementation, we have seen the API endpoint implementation for the web frameworks, and what else? Agentic AI framework structure. And I can also use LangServe if I want to deploy my application into a server and then monitor it by using LangFuse. You can also use LangFuse for monitoring your entire server, entire what do you call the call of the models. You can see like what is the cost per tokens, what is the number of tokens generated for each call, and what else. You can also see many more things when you use LangFuse.